Alrighty, welcome to my Algebra 1 students. Here we are today and we are going to be doing lesson 1.7. 1.7 is all about your different types of properties here in math. So we're going to talk about your commutative property, associative property, distributing property, and how we can use those properties to help us simplify algebraic expressions. And so something that also goes kind of hand in hand with simplifying your expressions is being to understand what are like terms and then combining those like terms, because that's basically the same thing as simplifying your expression. We're just going to make it look a little nicer and not so messy. So we're not necessarily going to find your solution to the problems. We're more so just going to simplify them and make them look easier to solve. So we are going to review our property rules, and then we will go through about 4 examples here, okay? Keep watching along for questions that you have to answer throughout the video. Alrighty, so the first ones we want to talk about, I don't know why these text boxes keep coming up, is your commutative and your associative. So I'm going to be honest with you guys, I don't always remember these either. And so I would really suggest writing down a couple notes on this. So, you know, maybe your commutative property, you just write down an example. Sometimes I do better with just an example, but you know what? Some people might have more of a mind that do better with a written out description. You know, if you're better at, you know, reading or analyzing kind of things, that might work too on how you write it down. So your commutative property means that you can add numbers in any order and multiply numbers in any order. So it's just reinforcing that, you know, if I did 2 plus 7, which is 9, 7 plus 2 is also going to be 9. So it doesn't matter what order I add them in or what order I multiply them in. I'm still going to get the same solution. All right, that's basically what commutative property means. It means I can move them around, but it's still going to be the same, okay? Associative property, this is the one where they have parentheses around it. So it says when you are only adding or only multiplying, you can group any of the numbers together. So you can add in some parentheses. So in this case, they have the same sentence. Notice it says 6 plus 8 plus 2, and on this side of the equation it says 6 plus 8 plus 2. The thing is that's different is the parentheses around the 6 and the 8, and then they did it around the 8 and the 2. Same rule applies for your multiplication as you go through. So they're just rules to help us understand that they would mean the same and that we can move things around, or we can kind of change our parentheses to what is going to be easier for us to solve. Let's go ahead and then look at some examples. Okay, I think we had 4 examples to look at. Alrighty, so number 1 is using the commutative and associative properties. To be honest with you guys, I'm pretty sure I know that you can multiply these out, okay? Longhand them, please. I am trying to use it without a calculator. But they just want us to simplify each expression. Now, I said that we weren't necessarily going to solve the problems, but in this case, because the problems are all numbers, I can solve them out. In the case that I have a variable in my equation and they don't tell me what my variable is, am I going to be able to solve it? No. So in this case, we can actually get numbers. And so what they're talking about in that associative or commutative property is that you can move things around and still get the same answer. So to me, looking at this problem, I have 4 and 9 and 25. To be honest with you, 4 and 25 seems a lot easier to multiply than 4 and 9. Maybe you already know 4 and 9 right away, but I already know what 4 and 25 is. So I'm actually going to rewrite this around because I want to show you what this is going to do. So I'm using that associative property, commutative property. Oh, here we go. Already messing them up. Because I already know what 4 and 25 is. So I could easily multiply that because I'm thinking about quarters. 4 quarters equals $1, so it's $1. So then I just have 9 times then 100. 9 times 100, that's easy. That's 900. Because then if I did, if I went backwards and I went, okay, 4 and 9 is 36. 36 times 25? Is that still the same? I hope I'm doing this right. Yeah, so it gives you 900. But that's not as easy to multiply in your head. So the same thing's going to go for over here. I think I'm going to move it too. I'm going to use that commutative property again because I know that 25 and 75 are 100. I'm just going to make it easier so I can add it in my head. 25 and 75 is 100 plus 48 equals 148. So I'm just finding ways to make it simpler so that I can mental math this. Okay. Let's keep going. Alrighty, so the last property we are going to talk about is your distributing property. This is probably my favorite property, to be honest with you guys. Not sure why. It says you can multiply a number by a sum or multiply each addend by the number and then add the results is, oh gosh, let's read it again. You can multiply a number by a sum or multiply each addend by the number and then add. The result is the same. So I'm pretty sure I might have done this in one class, but if you have a distributing property, so they're giving this example, you could start off by going, okay, 3 times 4, okay, plus 3 times 8, and add those, but also you can use your order of operations and solve the inside part first, because 4 plus 8 would give me 12, so 3 times 12, that's 36. If I solved it out here, I'd have 3 times 4 is 12, plus then 3 times 8 is 24, which also would give me 36. So there's multiple ways to do it. You can either distribute first, or you can solve in the parentheses. The tricky part gets to be when we have variables in there. And if we have a variable in our parentheses, then we can't obviously solve unless they tell us what that variable is. Alrighty, so here is what we are doing for this one. I know it looks pretty simple, or you're like, oh, let me just grab a calculator and solve it out. Read our directions first, okay? It says using the distributive property with mental math. Mental math. Again, I'm not wanting no calculators for this problem, okay? Write each product using the distributing property and then simplify. Basically, I just want to try and find the mental math capacity of this, okay? So here's one way you can do it, and I'm going to challenge you to try and do B here and show out your work on this assignment. So what they're going to do is I want to change the inside part to an addition problem, something that's going to be really easy for me to multiply. And so I would say that I'm going to break this down into 100 plus 3. Because isn't 100 plus 3 103? Now I'm just going to use this distributing property, and it's a lot simpler than writing it all out. Because 15 times 100, and then I'd have 15 times 3. That's not a good 0, plus 15 times 3. All right, well, 15 times 100 means I have 1,500. Remember, you just add the same amount of zeros onto this. And then plus, and 15 plus 3, that is 45. So add them together, 1,545. With no calculator, this is just my mental math, okay? I'm challenging you to problem number B here. This one I would suggest maybe rounding it up and subtracting by 1 in your parentheses. I want you to put in a good estimate into what you think B is in the box. All right, when you come back, we will discuss the answer. Continue with my mental math and to not use a calculator. I know that 19 is the same as 20 minus 1. That was my suggestion to you. And then I just distributed it out. So I did 6 to 20 and 6 to 1. 6 times 20 is 120. 6 times 1 is 6. I'm subtracting them this time. And I would get about an answer of 114. So I'm looking for about that number, okay? Again, we didn't, this is the exact answers, but we're using mental math or our estimation skills to solve these out without a calculator. Alrighty, so something else I wanted to review with you quickly is I already wrote down some problems here because I want to be able to kind of remind you of just a couple things here. Let me go ahead and change the color of the pen here though. And what I wanted to remind you of is your different terms in your equations, okay? So one thing to notice and one thing we were talking about were like terms. Like terms are things that are like. So in this case and in this black equation here, the 4x and 3x are like terms. They both have a coefficient, so a number in front, and they both have the variable x. Okay, that is a like term. Something else, I could write another example. Okay, maybe right side. All right, in this case, your constants, your 7 and your 2, okay, I'm going to also write this constant, are your like terms. So those are things that can combine. The other thing, though, to think about is that if you have an x squared and an x, are those like terms? They both have x, right? They both have a variable of x, but these are not like terms. I cannot combine them because of this little exponent. This one would also have to be raised to a power of 2 for it to be a like term. So let's continue on and look at some combining of your like terms. Alrighty, so I'm going to challenge you to A and B here, and then we will go through those two answers. So go ahead, pause the video. It's going to pause it for you anyways to answer these. I want you to try these out and put your answer in the boxes. Alrighty, coming back. So my expression here, 12x plus 30x, they're both like terms, so I just add it. What's 12 plus 30? It's 42. Keep that x, 42x. My y's are like terms because they are both squared. Remember, if you just have y squared, it's like saying 1y. So in this case, I'd take 6.8 minus 1, which is 5.8, keep the y squared. And the last one is a trick question, all right? I cannot simplify this any further. The only thing you could possibly do is use your commutative property and just write it like this. And the only reason you'd want to write it like this is a lot of times mathematicians will always put the variable that has the bigger exponent first. So like left, all the way to the left, so when you read it right, left to right. But these ends are not like terms because this one's raised to the second power. So I cannot add the 11 and the 4 together and keep that end squared. So this is what I'm going to have. We got one more problem. I'm really trying to cram it in here, so bear with me. Pause along the way if you need to. Alrighty. So your last problem is to simplify the following expression. So I'm going to underline it. Justify each step with an operation or property. I am also going to challenge you to this one. Haha. I think you can do it though. Really all I want from you is to find your solution or the simplified version and put it in the box. And I will come back and I will show you all of the steps and the operations that they mean. Alrighty, to be honest with you, I took way less steps than the actual book did. So here's what I did. I used my distributing property. So I get 2x plus 12 plus 38. Then what I did is I used my associative property and I just moved around these 2 and 3. That way they're right next to each other and I can easily combine them because I know that they're like terms. 2 plus 3 is 5, so 5x plus 12 is my final solution. Thank you so much for continuing on with this video and continuing practicing your skills here in math. Feel free to let me know if you've got any questions. Make sure to submit this as well. I will talk to you later. Bye-bye.